Okay, listen dear students. 33 question. This 33 question, half-life of a reaction is 46 minutes when the initial concentration of reactant is 0.4 mole per liter. When the half-life is 92 minutes, when the initial concentration is 0.02, find the order of the reaction. So we know one relation, half-life T of is inversely proportional to 1 by a to the power of n minus 1. Okay, let's see that T1 half by T2 half is equals to A2 by A1 whole to the power of n minus 1. See, there we have to find out n value. See, first half-life period, how much they gave? 46 minutes. 46 by 92 is equals to the initial concentration of second half-life period is concentration is 0.2. A2 is 0.2. Then A1 is 0.4 whole to the power of n minus 1. Okay, it's very clear. See, 46 1 is 46, 2 times it will cancel. It is a 2 times it will cancel. Means 1 by 2 is equals to 1 by 2 whole to the power of n minus 1. See, 1 by 2 power 0 means sorry, not power 0 ma, 1 by 2 whole power 1 is equals to 1 by 2 whole to the power of n minus 1. From this n minus 1 is equal to 1, then n is equals to 1 plus 1 is equal to 2, means second order reaction. So therefore order of reaction is two second order reaction. So whenever two half-life periods and their initial concentrations they given, we have one relation, half-life period is directly proportional to 1 by a whole to the power of n minus 1. According to that, by using that relation, we can find out the order of the reaction. That is known as half-life method is useful to find out the order of the reaction. Then the first half-life period by second half-life period is equal to a2 by a1 whole to the power of n minus 1. Okay, then n value is 2 came. Okay, students. Okay, let's go for next question. 34. The rate constant of reaction at given temperature 200 Kelvin is 10 times less than the rate constant at 400 kelvins. What is the activation energy of the reaction? Already this kind of questions we did earlier only. Let's see. 34. K2 is equals to, means at higher temperature 400 kelvins temperature, K2 is equals to 10 into K1. 10 into K1. So here the formula is equals to log K2 by K1 is equals to EA by 2.303 R. EA by 2.303 R into 1 by T1 minus 1 by T2. So their activation energy we need to find out. Log K2 is equals to 10 K1 by K1. K1 will cancel. Log 10 value is equal to 1. Log 10 value is equals to 1. EA by R value. R is equals to gas constant. Just according to the options, R value no need to substitute any value. So is equals to 2.303 R into 1 by initial first temperature T1 is equals to 200 minus another at T2 higher temperature is 400 kelvins. Okay, see log 10 is equals to EA by 2.303 R into 400 minus 200 by 200 into 400. Then it will comes 200. Then this 200 will cancel. Okay. Then EA is equal, it is 1. 1 is equals to EA by 2.303 R into 1 by 400. 1 by 400. Then EA activation energy is equals to 2.303 into 400 into R is nothing but how much ma? It is approximately 921.2. 921.2 R. 921.2 R. Okay, so the answer is second option is correct. Second option is correct. So here the simple logic is when the temperature is increased from 200 Kelvin to 400 Kelvins, means at 400 Kelvins, sorry, at 200 Kelvins, the rate is 10 times less when compared that 400 Kelvins. Means 400 Kelvins temperature, at 400 Kelvins temperature, the rate is 10 times more when compared to 200 Kelvins. At that temperature change, we have to find out the activation energy of the reaction. So how much we got? 921.2 R. R value means gas constant. So this value activation energy in joules means R value is 8.314 joules per mole Kelvin inverse we need to take. R value activation energy they gave in calories means R value is equal to 2 calories. So like according to the options units R value we need to consider. Okay, let's see 35 question. What is the rate expression of this reaction? See, the rate determining step is, we know that slow step is rate determining step. Rate determining step. Okay, it is very clear. So which is slow step among these? O plus O3 is converted into 2O2 is a slow step. That's why it is rate determining step. Therefore, for this reaction, the rate expression, rate is equals to K into concentration of O3 power 1 into concentration of O. Concentration of O. So, okay, let's see this oxygen atom means nascent oxygen atom. I am writing as like this. For our convenience, this concentration of O is equals to concentration of O into O2 by concentration of O2. This just then O into O means it becomes O3 by O2. So this rate expression is equals to K into concentration of O3 into concentration of O3 by concentration of O2. Okay. Now the rate is equals to K into concentration of O3 square means here power 1 is there, then it becomes 2. Order with respect to ozone is 2 and order with respect to O2 is equals to -1. Okay. So this is the rate expression. So total order of this reaction they're not asked, but if they're asked this type of questions, what is the total order or order of the reaction or order of reaction? Order of reaction is equal to 2 minus 1 is equal to 1 means first order reaction only, and order with respect to O3 is equal to 2, and in the same way the order with respect to O2 is equal to -1. So this is also another, there is a chance for asking this kind of questions also from this data. Okay students, so the correct answer is second option. The rate expression, according to the rate law, rate expression, rate is equal to K into O3 square into O2 power -1. Okay, let's see next. 36th question. 50% of reaction is completed in 16 minutes under similar conditions. 75% of the reaction is completed in 48 minutes. Then the order of the reaction will be, so we know that we have some relations. T 50% is equal to 16 minutes. Okay, T 75% is equal to 48 minutes. Okay, 48 is nothing but 3 into 16 means T 75% is equal to 3 into T half. Okay, it indicates that what is the order of the reaction, ma? It indicates that T 75% is equal to 3 times of the T half, means it indicates that order of the reaction is 2. So N is equal to 2 means second order reaction. Second order reaction. In the same way, if N is equal to 1 means T 75% is equal to 2 T half. This is for first order reaction relation. Okay, this is for second order relation. T 75% is equal to 3 T half. Okay students, let's see 37 question. Next 37, it's very easy. The reaction process A plus B is converted into products. The rate of reaction is second order with respect to A and zero order with respect to B. Okay, so for this rate expression, A plus B is converted into products. Okay, order with respect to A is equal to 2, comma, order with respect to B is equal to 0, then the rate is equal to K into A square into B power 0 is nothing but K into A square. It is very clear. Now, in this question what they are asked, when 1.0 moles of each reactant is taken in 1 liter vessel, means concentration of A is equal to 1 molar and concentration of B is also is equal to 1 molar. The initial rate is equal to 1 into 10 to the power of minus 2 mole per liter. When the rate of the reaction, when 50% of the reactants converted into products, then what is the rate we have to calculate. So the R1 is equals to K into concentration of A. Concentration of A means 1. Concentration of A. Concentration of A, how much? 1 molar they gave, 1 square is equals to R1 is equals to K is equals to how much they gave? 1 into 10 to the power of minus 2 mole per liter, second inverse. means molar second inverse. Okay, it's very clear. When 50% of reactants are converted into products, means concentration of A. If concentration of A is equals to 1 by 2. 1 by 2 means 0.5 molar. In that case, what is the rate expression or rate they asked? See, in that case, rate is equals to K into concentration of A whole square, 1 by 2 whole square is nothing but 10 to the power of minus 2 into 1 by 4. Mole second inverse, molar second inverse or mole per liter second inverse. 1 by 4 value is 1 by 4 value is nothing but 1 by 4 is nothing but 0.25. 0.5, 2 point, okay, listen dear students. See here, 1 by 2 is nothing but 0.5 whole square. 0.5 whole square means 5 5 are 25. Then it is nothing but 0.25 into 10 to the power of minus 2 m second inverse is nothing but 2.5. 2.5 into 10 to the power of minus 3 m second inverse. So the answer is second option is correct. Okay, see here, initially concentration of A and concentration of B is equal to 1 molar. Okay, at that case the rate is equal to 10 to the power of minus 2 mole inverse. Then the rate is equal to rate constant. Now what is the rate when the concentration of A becomes half? Concentration of A becomes half, then the rate is equal to, already from the above data rate constant we are calculated, then K is equal to 10 to the power of minus 2, then the concentration of A is equal to 0.5 molar, then the rate of reaction is equal to 2.5 into 10 to the power of minus 3 molar second inverse or mole per liter second inverse. Okay, let's see next question. 38th question. SO2 Cl2 is converted into SO2 plus Cl2 is first order reaction. K value they gave at 320 kelvins. The percentage of SO2 Cl2 decomposes on heating for 90 minutes is. So at 90 minutes, how much percentage of SO2 Cl2 is decomposed? That value they are asked. So 38 is first order reaction. See, for first order reactions, K is equal to 2.303 by T into log A by A minus X. See here in this, what we have to calculate at 90 minutes time. 90 minutes time, the percentage of SO2 Cl2 decompose means how much percentage of SO2 Cl2 decompose, that same quantity of product will form. Means X value we have to calculate. So in this question, X value we have to calculate. X percentage of X. Okay, see, let A is equal to initial percentage of A is equal to 100%, then the time is equal to 90, then the K value also they gave. What is the K value? 2.2 into 10 to the power of minus 5 means 2.2 into 10 to the power of minus 5 is equals to 2.303 by t. Time is equals to, must should be, we have to express in seconds. 90 into 60 into log 100 by 100 minus x. 100 by 100 minus x. Then log 100 by 100 minus x is equal to 2.2 into 10 to the power of minus 5 into 90 into 60 divided by 2.303. This is on simplification. We will get approximately here 0 90 is nothing but 9 into 10, 60 is nothing but 6 into 10, then 2.2 into 9 into 6 into 10 to the power of minus 3 by 2.303. Then we'll get 51.58 into 10 to the power of minus 3 is nothing but 0.05158 is approximately 0.052. 0.052. Now let's see 100 by 100 minus x value. If log we have to remove means it becomes a 10 to the power of 0.052. See, 10 to the power of 0.052 means anti-logarithm of 0.052 we need to check. Then is equal to 100 by 100 minus x is equal to 1.127. Anti-logarithm of 0.052 value is 1.127. Then 100 is equals to 1.127 into 100 minus x. Then on simplification, that x value will comes around 11.26 percentage. Okay, so the correct answer is fourth option, 11.18 or approximately 11.26 percentage we got. So the correct answer is fourth one. See here, the main important thing is the given reaction is first order reaction. K is equal to 2.303 by T into log A by A minus X. How much percentage of reactant decompose the same amount of product will forms. See here, A is initial concentration and X is equal to the amount of product formed. Means A minus X is equal to amount of reactant left in the reaction at 90 minutes. A minus X means final concentration of reactant, that is A minus X. But they are not asked final concentration of reactant. They are asked how much amount of product formed, or percentage of amount of product formed, or percentage of reactant left. Sorry, percentage of reactant decomposed they are asked. That is X we need to calculate. See, the X is 11.26 percentage came. Okay, let's see next. 39. A is converted into X moles of product. Concentration of A is equal to 2.2 millimolar. The rate was found to be 2.4. On reducing the concentration of A becomes half. The rate changes 0.6. Then the order of the reaction they're asked. See the first one. For this given equation, rate expression R is equals to A power X K into A power X. Okay, according to that, initial rate, initial concentration at concentration is 2.2 millimolar. The rate was found to be 2.4 millimolar second inverse. So the R1 is equals to 2.4 millimolar second inverse at concentration of A is equals to 2.2 millimolar. Now 2.4 millimolar second inverse is equals to K into 2.2 whole power x. This is one. The second is the concentration of A is changed. The reduced concentration of A becomes half. At that rate is equals to means 0.6 millimolar. Second inverse is equals to K into concentration of A becomes half. A becomes half means 1 point, otherwise 2.2 by 2 whole power x. This is equation 2. Then we have to solve this equation. 1 by 2 we did. Then 2.4 by 0.6 is equal to 2.2 whole power x by 2.2 by 2 whole power x is equal to, it will be cancelled 4 times. This 2.2 will cancel. Then 4 is equal to 2 power x will comes. Then 4 is nothing but 2 square is equal to 2 power x. Then x is equal to 2. X is equal to 2 means order with respect to A. Order with respect to A is equal to order of reaction is equal to 2. So the answer is second option. Okay, see here, R1 value they gave, at R1 concentration of A they gave, R2 value they gave, concentration of reactant also they gave. So we have to find out the order. Order means let it be x. Rate expression R is equal to K into A power x. That x value we are finding out. Okay, let's see next. Next question. 40th, the rate of reaction at different times they given below. Time intervals they gave, the rate also they gave. So what is the order of the reaction they asked? See, approximately the rate is 2.8 into 10 to the power of minus 2, 2.8 into 10 to the power of minus 2. If time is changing, time is increases, but rate is a constant. 2.79 means it is also approximately 2.8 into 10 to the power of minus 2 only. Okay, means time is independent. For zero order reactions, rate does not changes with time. Zero order reactions rate does not changes with time. See here, time is increasing, but rate is constant. If time changes, t changed, but rate is constant. That's why this is, therefore order of reaction is zero order reaction. Okay, let's see 41. In isomerization of cyclopropane is converted into cyclopropane is converted into propene or propanine is first order reaction. At 760 kelvins temperature, 85% of the sample of cyclopropane changes into cyclopropene. Means 85% reactant is consumed, means 85% product is formed in 79 minutes. Calculate the rate constant, K value they asked. So the direct formula K is equals to 2.303 by T. into log a by a minus x, log a by a minus x. Okay, now k is equals to 2.303 by t, time interval 79 minutes, because k units also they gave minute inverse, that's why 79 directly we need to take. Log initial concentration of cyclopropane is 100 percentage by final concentration of cyclopropane, means 85 percentage of cyclopropane is converted into propane, means 85 percentage product is formed, that is x is equal to 85 percentage. Here x is equal to 85 percentage, that's why 100 minus 85. Okay, now is nothing but 2.303 by 79 into log 100 by 15. Okay, is nothing but 2.303 by 79 into log a by b is nothing but log a minus log b. Log 100 value is equal to 2 minus log 15 value is log 15 value is log 5 plus log 3. Then 2.303 by 79 into 2 minus log 5 value is equal to 0.7, and log 3 value is 0. Log 3 value is 0.5 approximately, means 0.47 something will come, is approximately we are taking 0.5, is nothing but log 7 plus logs 5 plus log 3 value is 1.2, 2 minus 1.2 is nothing but 0.8. This is on simplification, we will get approximately 2.33 into 10 to the power of minus 2 minute inverse. So the answer is first option, sorry, 2.33 into 10 to the power of minus 2 means third option is correct. Okay, means approximately 2.4 into 10 to the power of minus 2, nearer to this value, that's why third option is correct. Okay, let's see next 42. 42 directly theoretical question mark. For a reaction followed in first order kinetics, means n is equal to 1, means first order reaction, the following statements are correct. The time taken for the completion of t 75 percentage is equal to 2 t hours. So we know that in first order reactions, if n equals to 1, means first order reaction t 75 percentage is equal to 2 into t 50 percentage. So the first option, first statement is correct. Okay, next let's see 43 question. 1 by T4 can be, means T 25 percentage of reaction can be taken as the time taken for the conversion of reactants dropped from 3 by 4th of the initial value, means initial concentration is maybe 1, then final concentration of reactants is equal to 3 by 4, then the rate constant for the first order reaction is K. Find time required for 25 percentage of the time we need to calculate. See the first order reactions, 43, first order reaction, K is equals to 2.303 by T 1 by 4 into log initial concentration R naught by R, final concentration of reactants. Then the rate constant is equal to K is equals to 2.303 by T 1 by 4 into log initial concentration is equal to 1, final concentration is equal to 3 by 4. is nothing but k is equals to 2.303 by t by 1 by 4 into log 1 by 3 by 4 is nothing but 4 by 3. 4 by 3 means log 4 minus log 3. Okay. Then log 4 value, we know that log 4 is nothing but 2 log 2. Then k is equals to 2.303 by t by